First of all, I want to thank all the speakers for this amazing presentation, truly innovative in a field that is a new frontier for civil and structural engineering. And I see also from the comments in the chat, enthusiastic comments. So thank you for the speakers and thank you also for the attendees. Now I leave the word to the FAB General Secretary, David Fernandez-Ordoñez, that he's here today with us to say some words about the FAB. And then we will open the roundtable discussion. Please, David.
It's nice to be here with you in this very, very interesting webinar. I think it has been a very, very interesting presentations, and also I think the discussion later will be great. I just wanted to say some things about the FIB that very shortly that maybe you'll be interested in. That is that we are pushing a lot of webinars now with the help of the very active and very good young members group in the FIB. I think you're seeing that, and we have more and more participants, and we like very much to distribute all this information. I think this is great. And I would like to just to tell you to check the next webinars and check that the PhD symposium that will be held at the end of August will be a free webinar, also 3-day presentations on research in concrete that you will be able to attend. So take a look at the FIB website and maybe you can register for free in that case. Also the symposium that was going to be in Shanghai will be online, and this will have a reduced cost, not for free, but maybe you'll be interested in also 3-day event that will have a lot of presentations and a lot of information there for you. Something else I wanted to say is that we are implementing in the FIB, because we are trying to support a lot the young members, is that to try to implement a mentor program. So be aware that in the next times we will start with this mentor program, and maybe for FIB members, of course, you'll be interested in participating and getting in contact with the more experienced FIB members that are going to be around. No? So this is something that you may be interested in that. And just one last thing is that we are more and more trying to implement the ability of FIB members to view the documents, and we have implemented the viewers, so FIB members can take a look at the documents online. And this is something that in these times that we are at home many times, it may be something very, very interesting. So this is more or less what I wanted to share with you, that we are very happy with these events, and that we are trying that persons like Costantino and Marta really can have their place around here. And any of you that want to be involved, you can talk to them and see that it's quite easy. And we are happy to have people around. So I'm very happy to be here to say hello to you and have a good discussion now. Marta, I go back to you.
Thank you. Yes, thank you very much, David. And yes, I've seen that there are a lot of questions in the chat also about how to join the FIB task group 2.11. So as for this task group, but other task group of the FIB, if you are a member, you can easily apply from your profile, or you can also send a message to David or one of us if you need help, and we will help you to be engaged with our activities of the FIB Commission and task groups.
Yes, there is also there is a very active young members group in many countries. Italy is a very good example, but many other countries too. So if you are from a country and you want to get in contact, or even create a group of people to start discussing, please get in contact with Marta or with anybody of us, and we'll help you with this too.
I think we can start with the roundtable discussion. So I asked to all the panelists to share their videos and microphone open. And we will start reading the question online and the Q&A form. Costantino, please, if you can start with a question, I will stop sharing.
Okay, yes, just a second. Okay, I think we have collected many questions. Some of them we have tried to address in the chat itself. So I would start, first of all, I would say that we are a little bit late with times, and I hope that all the presenters are willing to continue a little bit this discussion that we are going to start. So we are a bit late, but I think it has been worthy to listen to the presentation of everybody. I will start with the sequence that we have used in the presentation. So starting from the fresh state and then going through the other presentation. I will open the question and of course you are free to respond. There is the first question that I have for fresh state. It's very interesting because one person from the audience asked, talking about the elastic buckling failure mode in the fresh state, what do you think triggers the deformation in elastic buckling case? So the viscous deformation or low elastic properties? Because we know that in the fresh state, the material is very soft. So maybe Jacques can start the answer and then we can enlarge the discussion.
Yes, Costantino, that's a very important question and also very relevant. I'm not entirely sure. My field is more into the plastic yielding of the concrete. So I don't have a lot of experience with elastic buckling since our material for some reason also has a lot of stiffness. So we don't really experience a lot of elastic buckling. But if I have to guess, it probably depends at what time during the print the element fails or buckles, because if it's during the viscous phase, then it's probably due to the viscous properties. But if it's in the elastic phase, when it structurates, then it's most likely more based on the elastic response. So I think there's a few aspects to this question, and to be honest, I don't have a direct answer for you on that one.
Maybe I can switch the question to Freek that has worked also on this topic.
Yeah, it's actually it's a very complex issue actually, because we're dealing with a material that is making a transition from viscoelastic to elastoplastic to elastic material. So and then when you're printing, you're dealing with a material that the bottom layers are further developed than the top layers, and therefore also can be in another state. So it's not so clear. I don't think you can really make a clear distinction between viscous failure or very pliable elastic failure. But in any case, there can be a point that, and it's not uncommon to happen. At least it happened a lot to us. That there is some kind of movement start which results in a loss of stability, and that causes a kind of buckling failure. But it's kind of a point that's still open for discussions. At the conference last week, Lex Reiter from ETH proposed a failure criterion that's more based on a maximum strain than on a stress or a buckling criterion. So it's still a bit open for discussion.
I agree.
I know that Jacques has a material that structurates really quickly, so that is so you would not experience it maybe as soon as some others, including us.
Yeah, I agree, because also it's very difficult to understand if the instability shape is similar to those that we know for conventional materials, because I think that since the stacking layers are evolving, so the shape probably is very different from the conventional materials. Okay, so I think, Marta, we can move to the second question.
Yes, still to Jacques, we have another question about the Poisson ratio. So 0.3 is a reasonable value for fresh concrete.
Yeah, that is one of the assumptions that we made in our studies. So at the moment, not that I'm aware of, is there any test to determine the Poisson's ratio for a material in the fresh state. So from works that I saw, I know Rob Wolfs and Akke Seker, for instance, did a lot of modeling for 3D concrete printing. and they also assume the value of 0.3. So at the moment, it's a good assumption to make, but you can probably, the more workable the material is, the more it will want to tend to go towards 0.5, but that's obviously too high. So my feeling is 0.3 to 0.35 should be a reasonable estimate.
Well, if I may say something again there, so we actually did tests on the determination of the Poisson ratio as well, but it is in the fresh states, especially in the early stages of development of really 0 to 5, 10 minutes, it's very tricky to measure it. I mean, to measure it correctly. So we did some attempts, and indeed we came to values of above 0.4 for very, very fresh concrete. But it's very sensitive to errors in the measuring. So it's, but on the other hand, it's also a parameter that is quite important in the structural analysis. So it's a bit tricky. So, it's really time dependent and dependent on the structuration rate of your material.
Yeah.
Thank you.
I totally agree. I had a very quick question again to Jacques, because he showed some graphs about the evolution of tensile strength against time. I'm interested to know why did you consider also very long time gap, so more than 1 hour? So just to understand what is the practical use.
Yeah, so for practical use, 1 hour is probably a bit excessive. That's not really something that will occur on site. But if you have let's call it a printer breakdown, for some reason, one of the motors on the printer, is not working anymore, or there's perhaps an injury, hopefully not on site, stuff like that can actually stop the print, and then you stop in the printing process. And that delay can be, anywhere from minutes or perhaps seconds all the way to hours. So in that case, when you then continue the printing, you should know what your strength is in that interlayer, because that will then be the weak spot in the structure. So you should be able to account for that by changing your structural design, or some other solution, if you have some epoxy or any type of application that you want to put on that layer, that's similar to conventional cold joint formation.
Okay, thanks for your answer. Well, I think, Marta, we can move to the reinforcement topic.
Mm-hmm.
I'll leave you the word.
Yes, we have some questions to David. So the first one is about the failure mode observed in the beams tested with textile reinforcement. So basically, the question is about which kind of failure mode was observed, and if all the specimens achieved the same failure mode, if you observed shear cracks in the stress zone, or other kind of failure mechanisms, basically.
When we did the test, almost all the samples failed due to the tensile rupture of the textile. In total, we tested 22 samples. Only 2 samples, 1 cast beam, 1 printed beam failed due to the combined tensile rupture of the textile and the shear delamination of the textile between the textile and the concrete. So, based on our preliminary test, we think, so if, the textile are properly placed with epoxy coated, with fresh epoxy coated, it can avoid a shear failure. Yeah.
Okay, anybody wants to add something? I have curiosity about the images that you have showed. So I saw how your printer placed the concrete over the reinforcement. Yeah. But do you think there would be a way to place reinforcement automatically, or at the moment you are using only manual placement of reinforcement?
Yes, this is a really good question. Our plan, so I can share you with some of our recent research plans. So we are trying to place the textile automatically. And one of my colleagues, he is trying to develop first initial version or textile placement machine. But due to the pandemic, so all the labs are closed. So we have to wait to reopen all the labs. Yeah.
Laboratories are COVID dependent, so.
Yeah. Thank you.
Okay, now we have another question. I think we can start from David, but it is quite general. It is about various of partial safety factors to be used in the design of the digital fabricated members and structures. So let's start from David, but I think it's a quite tricky point.
And I think I would like to remind us, I think almost all of us, we attended the DC 2020. During DC 2020, we learned a lot from many experts, especially for the structure design part. Many people mentioned the partial safety factor for 3D printed concrete, for 3D concrete printed structures. Some people mentioned, I think Freek mentioned the safety, partial safety factor or two. I think this is just want to, sorry.
Oh no, it's just, I mean,
Okay.
it was a guesstimate.
Yeah. So my understanding is at this stage, because we do not have enough knowledge for 3D printed concrete structures, I think a safety factor or two can guarantee we can use the structure safely. But if we are able to print the concrete, I mean, with very good quality, I think a safety factor or two may we need to use much more materials. I mean, in my numerical method, so I didn't assume any safety factor. But as you can see from the curve, so I assume the concrete has perfectly, plastic, perfectly plastic curve. This is to some extent, this overestimate the real behavior of the concrete. But even though I overestimated the real performance of the concrete, you can see that in most cases, the prediction results are still less than the experimental values. So I think, I don't know the answer for this one, but I think so. If we have a factor or two, even I think 1.5 should be safe enough. This is my understanding. Yeah, if we have a good printing quality concrete, yeah, that's the basis.
But I think this is an interesting topic, but also we should distinguish between the maybe different safety format philosophy due to digital fabrication and due to textile reinforcement. So also if we have textile reinforcement and we have a conventional element, safety format philosophy, so it's not clear. Because if you do this partial safety factor, then you need to reduce the reinforcement much more than concrete, because there are a lot of uncertainties, and also it's a brittle reinforcement. So I think this is an interesting topic, even out of the digital fabrication field. So if we have reinforcement materials that are not ductile, then yeah, it's partial safety factor good approach or global safety factor. Yeah. So I think this is very open point.
I think it's a statistical question, really. I mean, there are rules to determine what the material safety factor should be, and for a given failure probability, and assuming a certain Gaussian distribution with a 5% fractal percentage or probability of failure, etc. The thing is, I don't think we have nearly enough test results to really make these statistical analysis. So
I totally agree, Freek.
But also it's different.
So
if we have
it's really I mean, I would if you have a concrete printed structure which has more serious consequences in case of a failure, and it relies on the concrete, on the printed concrete structurally, then I would even be much, I would be much more conservative actually. I mean, I would go to up to safety factor of 5 maybe, or even more, because we have so few data on the material, on the scattering results it might result to due to printing parameters and differentiation. So it's I mean, I think the basis of the answer is that we actually have statistical rules to determine what the material safety factor should be, and if you have very few experimental results, which we do, then the safety factor that you need to apply will more or less explode. So it's
I think that it's not only a matter of, I think, the material scatter, but also about the structural behavior, because if we can have redistributions, then the concept is totally different than if we have a brittle failure. So I think
okay, I agree with that. Yes,
we have both things.
And the other thing is that we have to consider nowadays when we design a concrete structure, we assume that our model is certain. So for the reliability of the model, we assume a safety factor of 1, and we move everything on the material and on the action. But we do not know how the models that we are going to use, planar cross-section or things like this, or with special types of reinforcement, how reliable are they going to be? So in this sense, we can motivate just the philosophy of the Eurocode 7 for geotechnics, that they have a safety factor for the model itself. The thing is that, as Freek was saying, is that we do not know how safe our models are, because we do not have enough replicas to compare them with. So that is the issue that is required, the gap that we have to fill in order to bring the technology to real replicability and widespread applicability, and implement some structural design tools. Yeah.
I think this is why I think if we are as close we are as conventional concrete, I think we will make our lives easier. Maybe we are constraining us in a certain way, but yeah, I think maybe we have to fill a lot of gaps until we are able to design certain materials in a reliable way.
Yeah, because I think that technologies are very fast to be developed, but the time for approving and the time for creating the code, the framework are very slow. So we have this gap between technology and the time for, let's say, assuming that all the hypotheses are correct. So because we need more testing, and also for companies, because sometimes we can ask companies to make tests, but if there are no standards for tests in the hardened state, for instance, or fresh state, we cannot think about statistical variability, as Freek was saying, because with that statistical variability, we can adopt analytical models for safety factors. So something that needs to be better clarified. Okay, it's nice to hear that there are many open discussion and many open topics for research. So I think, I think Marta, we can move forward.
Yes, we have now one question for Liberato, for Professor Liberato Ferrara. It is about the aspect ratio of the fibers adopted to the low-bone strength at early stage.
Yeah. I've read the question by Roberto. Well, actually, you hit the point. In this study, in the study that I showed, we used the fiber as it was. So it was a commercial fiber. We picked it up and used it in our mix. Speaking about fiber hybridization, well, this is a concept that you can formulate, you can work on in different ways, because you can work with fibers with different aspect ratios, which can be useful at different stages of the fracture process, or even at different stages of the hardening or fluid to solid transition property. You can use with fibers of different materials, because some of them may be better in some stages and some of them may be better in some others. Actually, it's a wide field of research. The thing is that in the end, you should be able to find performance-based mixed design criteria. So and this is what are we working on now? Why are we going to hybridize the fiber reinforcement? What is the performance that we want to get? And so which are the ways we can tune the composition or the hybridization of the reinforcement to get the performance?
Correct.
Okay, perfect, thank you. And now we have another question for Jaime. It is about the optimization of the geometry. So basically, which is the most reliable way to validate the optimization of the geometry, and also something about softwares to be used for structural validation, if any?
Well, in my opinion, I think topology optimization, for example, is more like a conceptual design tool. So it's not really structural design. So I think we need other tools. Maybe for some projects, depending on the complexity, I think some strat and time modeling could be a good approach. I think if we have reinforcement in very complex shapes, I think we still need to develop maybe computational tools to deal with structural design in a simple but accurate way, because I think we have maybe more research-oriented software like maybe Diana, Athena, but I think it's difficult to do standard structural design with this software. So maybe I think we still have this gap to have simple but accurate tools to be developed.
Okay, I think we have also other questions for you. I don't know if someone else wants to add something about the optimization of the geometry. Okay.
I think there is an issue raised by one of the person of the audience, Fabrizio Vicario, that I think, Jaime, you can clarify, because it concerns about the CO2 emissions, because you said that cement use and cement content may be higher for compared to conventional casting methods. But I think also there are many other I don't know, functionalities, but also characteristics which can balance with this increment of cement content. But you can also add more on this.
Yeah, of course. In this, I think we need to do an holistic approach, because we can integrate some functionalities that in conventional structures we don't have, of insulation or other things. But still, it's a fact that I think most digital fabrication formulations use SEM1 concrete in high amounts. So then we have a high clinker. So I think it's maybe a lot of to improve there into the material formulations in order we don't start with this bad position. I think, of course, we have many other possibilities to balance. So I did not want to I think, to give the impression that I think we don't have potential of digital fabrication, but we have, I think, several points to address in order to make it easier that we can have more competitive digital fabrication structures.
Yes, I remember also a publication from ATH showing how these CO2 emissions can be very different if the complexity of the structure increases. So this also should be said, so that if the comparison is made also in terms of complexity, the gap is overcome actually. So, and the balance is in favor of digital fabrication with concrete instead of casting.
Yeah.
I think you have to evaluate the complex of the process and of the structure, because, for example, what is the CO2 impact of using the formworks? Cutting them, preparing them, and then disposing them after 3 or 4 usages at least, and you don't know how to dispose them. This is completely cut out. Obviously, if you just use the CO2 emission per cubic meter of material or per ton of material, you say, oh, come on. this is much higher. But this is something probably through which all of us, also from educational perspective, should work together to discard this cost per cubic meter, CO2 emission per cubic meter, because it's completely misleading.
I agree.
Parameter that you use, but then you have to multiply by the cubic meters used, and by the way, you make a structure, because likely we do not make cubes.
I think we have some of these rib slabs, and maybe there is not a lot of way to reduce material. You can increase functionality, so I think having more eco-friendly prefab mixes will maybe make easier. I think that the overall impact is much better when digital fabrication.
Yes, I think we need an holistic approach to assess clearly and with much more reliability the entire project. So this is the possible solution. I will go to the next question. I will ask to Freek this question because it's very interesting, and also to Jacques. There's one asking that since the main influencing parameter is workability, I would say also that many of the sources of uncertainties are in the fresh state. And also another influencing parameter is the rheological characteristics. As such, is there any work going on developing limit state of workability standards? So this is an interesting question. So can we say that there could be a workability limit state related to the, let's say, imperfections and also the variability of the material in the fresh state? What do you think, Freek?
I was hoping you would go to you first, Jacques.
So let's add the new limit state.
First, Freek.
I'm not entirely sure what you mean with the workability limit state. It's the whole concept of what is printable is also quite a bit still under development. There are a couple of things. First of all, the material needs to be pumpable, but whether it's pumpable depends on your pump and the hose length and everything. So that already is not a one-on-one thing. You could say if it has this, for instance, this limit yield stress, it's not pumpable or it is pumpable. It depends on your system. Then we have extrudability, which has to do with things like shape stability, but also segregation or non-segregation, so the stability of the material to not to get segregated or to get segregated. And then I think obviously one of the new ones that is really very specific to this technology is buildability. Basically the strength and stiffness of the material as a starting point, and then the speed at which it develops. But what you need there is also dependent on the object you want to print and the speed at which you want to print it. And then there is things like bond strength, and I think what's not yet really looked into is like a resistance to rupture when you take sharp corners. So some materials are better resistant to that than others. So there's really quite a lot, and if you ask if there's ongoing research in these areas, yes. There's quite a bit of ongoing research in this area from different groups that are looking at various aspects of this, but it's quite a wide, let's say, printability is quite a wide set of parameters. That the difficulty is that it's there's a very strong interrelation between the design of a certain element that you want to print, the process which you're using to print it, and the material that you're using. So it is very hard to, from one material to give it kind of general characteristics, because it's so closely related to both the process and the design. That makes it a complicated question to answer.
Yes, Freek, if I can just add to what you just said, to give an example to the audience, so what I believe is that for each setup, each printing setup, you'll have different materials. So for us, for instance, our normal concrete that we print here has about a static yield stress, say about 2,000 to 2,500 pascals, and that works great. But then you can, when we print with a lightweight foam concrete, I think it goes down to about 300 to 500 pascals. And then that prints great. So at the moment, it's very difficult to work with limit states because the technology is not standardized in the sense that the construction industry currently is, and the methods that they use. So there's various materials from lightweight concretes to alkali activated concretes, and obviously they are more stiff. So it really depends on the setup, on the pump, on the material. So it's very difficult to work with the limit states from what I know so far.
Yeah, totally agree.
Agree as well.
Okay, thank you. So we have now just 15 minutes, so we will try to answer to all the questions shortly. And another question to Freek is about the printing process outdoor. So how the environmental condition can influence.
Maybe I saw that question. It was maybe a misunderstanding, but the projects that I have shown and worked on myself were both, the elements were both printed indoors. So they were printed indoors and then shipped to a location, and there they were connected. Nevertheless, so if we look more at the examples that I was showing in the beginning, I think all of them, or most of them at least, were print on site. But it means well, basically you build a mini factory around your printer. So it's definitely an issue to keep the site conditions under control. The designs, the examples that I showed were not that sensitive, I think, to variations in printing quality, because it's basically just large walls, one story. But there is there will be environmental influence, and it's something that's not been researched very much yet. But we know that both humidity and temperature are certainly influential, and we even expect, but haven't really been able to research it yet, but we even expect that things like the draft, so the wind that blows over one area of printing, which is different than from the other side, could already have effects on things like the interlayer bond or shrinkage properties because of the dehydration. So as soon as you want to print more sophisticated elements outdoors, I would be very, very careful with the environmental conditions.
Yes, I think this is a very important topic for those applications on site. So, for instance, buildings with gantry system, for instance. Of course, the off-site production is a little bit more controlled.
Yeah, well, I think I mean I used to be a bit more skeptical about on-site printing than I
agree
now. But nevertheless, if you have designs that are sensitive to the print quality that you need, then I still think it's a bit tricky.
I think so.
Okay, thank you. And we have another question that is for you, but maybe it can also be answered by all. It's about the reinforcement. So now the problem of reinforcement is a barrier for development of 3D printing. So the question is about which is the best way to find a realistic and industrially viable way to, in a short period, for the development, large development and application of 3D printing on site.
I guess it's a bit the $1 million question.
Even 2 millions.
I mean, there are a lot of systems under development, let's say around the globe, by different research groups, and I think it's still a bit open which one is most, will be economically most viable. And it's questions about how well can you integrate the method with the printing, how well does it perform structurally, do you need very cheap or very expensive materials to do it? So it's I think, I mean, it's a problem that's kind of universally recognized, but the solution, I mean, it could also very well be kind of a hybrid, that you need some level of fibers, for instance, also to control problems like shrinkage, and you need to combine it with something else. But it's at this point, I do not really know where to put my money, so that's why I'm putting it in multiple places, studying different things. But there are nice studies being performed at different places. But so with conventional concrete, we're left with one standard method, or that takes 95%, I guess, of all reinforcement solutions. But I've no idea which one of the things that are under development now will be, let's say, in 10 or 15 years, be the one that remains, and all the other things have been cut off.
Yeah, exactly.
Also, okay. I would like to point out that I think the question was very oriented to 3D printing, but I think I always want to defend that digital fabrication is not only 3D printing. I think also maybe there could be easier ways to integrate reinforcement in other technologies. So I think 99% of the research is on 3D printing, but the other 1% maybe has also some important things, or to combine digital fabrication with conventional methods, not to do only digital fabrication. So I think there are many possibilities to have a look.
My understanding is, I mean, we have different reinforcement strategies. We cannot say so which reinforcement strategy is the best. I think it really depends on what kind of structures we are going to have. If we are going to have a very, I mean, as we are doing here in Lovebirds, we are focusing on some complex geometry structures. So it requires we find some reinforcement which can also, which is also flexible in geometry. So in this case, we consider textile. But I think if we are trying to have some structures which do not have that high designed load capacity, my understanding may be not right. So we can try to add some discrete fibers inside of the mix. So even though so we cannot achieve strain hardening response, the load capacity is much higher than the plain concrete structures. So my understanding, so it depends on what kind of structures we like. And also one point is, I think recently I read a newspaper which said in Netherlands they printed the world first 3D printed FRP bridge, which is really interesting. So maybe so in the future, so we are able to print concrete structures. I mean, when we print the concrete, we are able to print the reinforcement simulatedly at the same time. I think this can enable us to achieve a fully automated printing process. Yeah, thank you.
Thank you, David. I think that with this huge open issue, we can close this seminar because we have only 5 minutes left. After that time, Zoom will close. So we didn't expect to have this long discussion, but we had a very reactive and active audience. So I'm very happy that this seminar went in the right way. We had more or less between 80 and 90 attendees and 50 during the discussion time. I think that many issues and many topics are very open. So I think from the side of research, we have a lot to do in many of these multidisciplinary aspects. So with these words, I really want to thank you for everything and for giving us this opportunity to merge all these expertise and experiences. I thank you again, and I hope that within the FIB or also many other chance we will meet again and provide useful insight for speed up this process and see many other digital fabrication application around us. So thank you again very much. So Marta, I leave you the word to close the seminar.
So thank you. Thanks to all of you for your time, for your amazing presentation, valuable contributions. And thank you also for the attendees to being here today, 1 hour after the end of the expected end of the seminar. So it seems that they are really interested in this file. So maybe this can be the first step of future events on this topic. Maybe we will see. So thank you again. I'm really happy of this event. It was really a success. So hope to see you in the next future, in presence maybe.
Yeah,
and
I hope so.
Have a good night and good evening. Goodbye.
Bye.
Thank you. Bye.
Bye.
Goodbye.
Oh.